All right, now we're going to look at section 7.8, number 18, which was also to turn in. So we got the limit as x approaches pi over 2 from the left of the natural log of cosine of x divided by the natural log of tangent of x. Now, let's just remember what cosine x looks like. Okay, cosine x starts up top, and then as you get into here, this is pi, this is 2 pi, but anyway, at pi over 2, we're getting close. When we approach pi over 2 from the left, we're getting close to a height of 0 in a positive way. So this is really going to be the natural log of something approaching 0 in a positive way. And of course, natural log of 0, we know what that one looks like too, right? What's natural log look like? Looks like that. So as you approach 0 in a positive way, it explodes to negative infinity on top, right? So the top would approach negative infinity. The denominator, tangent of x, what does that look like? Well, it's kind of like that x cubed looking thing going vertical. But as we go to pi over 2 on the right side from the left, or from below, it explodes to positive infinity. So this would be the natural log of positive infinity. And of course, what's the natural log of positive infinity? As x gets huge, what height do you approach? Infinity. So we have a minus infinity over infinity form, okay, which is indeterminate. So really what we need to do is we need other methods, right? We need to see how this approaches. So I have no idea how to handle this algebraically, so we need something cool like L'Hopital's, right? It's a medical emergency. So anyway, so can I use L'Hopital's? L'Hopital's, what's our rules in section 7.8 on when we can use it? They got to be differentiable. Denominator can't be 0 on some open interval around this. So anyway, let's assume all that's fine. What is so if we use L'Hopital's with that infinity over infinity form, then this is going to equal the limit as x approaches pi over 2 from the left of, okay, so the derivative over the derivative, right? Derivative of natural log is 1 over times the derivative of what's inside. So the derivative of cosine, negative sine x, all over 1 over tangent x times the derivative of what's inside, derivative of tangent, secant squared. Okay, now it looks like we need to do a little manipulation here. So on top, how can I rewrite that? This is negative tangent, right? So it's minus sine over cosine. Sine over cosine is tangent, so I could write that as minus tangent squared x, which would be great if that would cancel here, but does it?
Wait, why is it squared?
I don't know. I was just doing math in my head. It's not squared yet. I was getting ahead of myself. It'd be nice if I could cancel this, but I can't cancel it because, you know, dividing by 1 over that, you got to flip and multiply. That's why. Anyway, so can I do that now? I'll use a different color. So instead of dividing by tangent, or dividing by 1 over tangent, I can multiply by tangent. So it's minus tangent squared on top. Okay, so I don't know. That's one way to do it. So does that help us at all? If I plug in pi over 2 to tangent, that'd be taking pi over 2 from the left. I'd still have a minus, I'd be taking tangent of x would approach positive infinity. I'd be squaring it and then taking the opposite. I still get minus infinity on top. So this doesn't work out too good, right?
Does tangent over secant equal anything?
Well, what might be better, instead of sticking with tangents and secants, changing it over to that, why don't we use sines and cosines and see if life can be any better? So that's what I did. So let's rewrite it. So that didn't really help because I still have minus infinity on top. secant's 1 over cosine, right? I mean, it might help. Instead of secant, could I write that as 1 over secant's 1 over cosine, right? Can we do that now? I could probably do that. Secant's 1 over cosine, so this is 1 over cosine quantity squared, which is 1 squared over cosine squared, right? So instead of secant squared, I got 1 over cosine squared. And then what's tangent, though? Tangent is sine over cosine, right? So let's write it that way. So on top, I've got minus sine squared over cosine squared for the tangent. And instead of dividing by 1 over cosine squared, what could I do? Multiply by the reciprocal, which is cosine squared over 1. That helps. Okay, and then we get limit as x goes to the power of 2 of minus sine x squared. Of course, sine x, what's sine look like? Sine looks like that, right? So here's pi over 2. What am I approaching? I'm approaching a height of 1 from the left. Pi over 2. So I'm approaching a height of 1. So I can do that. Now I can go ahead and plug in pi over 2 for x. And so it's going to equal minus 1 quantity squared, which is minus 1. Okay? So the trick there was, using L'Hopital's, but then we had to use some manipulation to make that write it in a way that makes sense, that we could actually figure out. So, you could always, I think I just went to sine cosine right away. So if you did that, let me just write to the right of this. Let me go back to what we had here. And if I had this deal, instead of, I'm just going to write minus sine x over cosine x on top, and then on the bottom, 1 over tangent is cotangent, right? So instead of sine over cosine, it's cosine over sine. And then secant's 1 over cosine, and it's quantity squared, so it's 1 over cosine x quantity squared. And I would get one of these to cancel out. And then so it's 1 over sine cosine on the bottom. So on top, I got sine x cosine x. And instead of dividing by 1 over sine cosine, I'd multiply by sine cosine. And then those cosines would cancel, and I get minus sine squared. So, yeah. If you're not sure if it doesn't take you to a better form, go back to sines and cosines and manipulate that way based on trig definitions. Okay. Perfect. All right. So that was 7-8, number 18. Thank you very much.